Hello learners. In this lecture, we'll try to take another two problems and then we'll finish off this entire series of lectures. So in the initial, for the syllabus, they have mentioned it here, concept of mixed design with and without admixture. So far, we had solved two numericals. That was with the help of admixture. Now we'll try to solve another two numericals without the help of admixtures, right? So this is what we are going to concentrate. Everything remains the same. Only the thing is we'll not add the admixture here. Yeah. So this is a question what we have. Design a concrete mix proportion for M20 grade of concrete is telling. Grade designation is M20. Type of cement is OPC 43 grade cement. Maximum nominal size is 20. Minimum cement content is 320. And then maximum water cement ratio is 0.55. Here for the slump they require 75 mm. Workability is 75. Exposure condition is mild. Degree of supervision is good. And this is coarse crushed angular aggregate 450 mm, 450 kg per cubic meter is the maximum cement. Right? Yeah. Chemical admixture, it's not used here, right? Rest all things we know. Yeah, now again as usual, go for this target strength for mixed proportioning. F dash ck is equal to fck plus 1.65. How much strength we require? M20 grade. So F dash ck will be 20 plus 1.65 into 4. This time this standard deviation is 4, because if you go back to the table quickly, I'll take you to the table. Yeah, for M20 falls here, so the assumed standard deviation is 4.0, right? Yeah, so we'll go there. Yeah, that is the reason they have taken 4. Do this, you will get 26.60. Next is selection of water cement ratio. Maximum water cement ratio, what we can get for a mild exposure is 0.55, because in the question the exposure condition is mild for us, right? For the mild exposure condition, we'll look into the table also. Yeah, for a mild exposure condition, okay, minimum cement is 300 and maximum free water cement ratio is 0.55. Minimum grade we have to use M20 only, so 0.55 is given here. Yeah, so 0.55, right? So based on experience we can take this as 0.5. Now again you can take even 0.45 also, but here we are taking 0.5, and this 0.5 is less than 0.55, hence it is okay. Next is selection of water content. So for selection of water content, we know how it has to be done, right? So the required water content may be established by an increase of about 3% for every additional 25 mm slump. First check what is the slump given for us. So the slump, what they are asking is 75 mm. Good. So if they're asking 75 mm slump, we'll go back to this drawing once again, and here we have to find it. That is for 20 mm size aggregate, the maximum water content is 186, right? But this table is for 50 mm. In the question, the slump given is 75 mm. From 50 to 75, there is an increase of 25, and for every 25 mm increase, you have to add a correction factor of 3%. So quickly we'll try to do that 3% correction. They have done it. 186 is what we got from the table, plus add 3% of that. 3 divided by 100 into 186 comes out to be 191.6 liters, right? Now since we are not going to make use of chemical admixture, this much water only we are going to take. In the previous cases what we used to do, then we used to take 30% of super plasticizer, and this 191.6 would have come down, but this time no plasticizer, directly we'll add water only, right? Yeah. So calculation of cement content is no water content divided by water cement ratio. Water content we are getting 191.6 divided by water cement ratio, what we have adopted is 0.6. Try to do this. 383 is a cement content what I'm getting according to the code for yeah, according to the code for the mild exposure. Yeah, for the mild exposure according to the code, minimum cement content has to be 300, but we are getting more than that. 300, we are getting 383, which is greater than 300. Next is proportion of volume of coarse aggregate and fine aggregate. For this again, what we are supposed to do, you have to go back to the question again. So it's telling us fine aggregate is belonging to zone 1. So fine aggregate is belonging to zone 1. Quickly we'll see into that table. Yeah, so for 20 mm and for zone 1, again that value is 0.60 only, right? And next what we need to understand about the water cement ratio. Yeah, yeah. So water cement ratio for 0.5, we are getting answer of 0.60. Yeah, we are getting a value of 0.60. The volume of fine aggregate content will be 1 minus 0.60, which comes out to be 0.40. Yeah, give me a minute. Yeah, so here we don't have to do any correction factor. The reason is that this particular table what we have, this particular table is prepared for 0.5 water cement ratio, and the water cement ratio what we have adopted is also 0.5, right? If I go back, what we have adopted is also 0.5. So there is no correction factor to be done. So directly whatever answer you're getting from the table, we got it as 0.60. So I'm taking 0.60 as coarse aggregate. Therefore volume of fine aggregate will be 1 minus 0.60, which comes out to be 0.40. Next, final mix calculation. Volume of concrete is 1 cubic meter. Volume of cement will be mass of cement divided by specific gravity of cement into 1 divided by 1000. Do this. Volume of water also we know how to do. Just substitute all these things, right? Which is equal to mass of cement. It's understood. Mass of cement. Yeah. So this is mass of volume of water is 191.6. From here you are going to get divided by 1 into 1 divided by 1000, right? And yeah, there's small mistake here. What you're supposed to do is don't take the specific gravity of not cement. This is specific gravity of water. Okay, this is specific gravity of water. Yeah, and this has to be 1, and here it is 3.15. This is okay. Therefore volume of all in aggregate will be, that is a total whatever you got here, that is 1 minus 0 minus, open the bracket, 0.122, and we'll add water also. That's it. The remaining what you're going to get, no, this will be my coarse aggregate and fine aggregate. If a mass of coarse aggregate will be D, this is 0.686 into 0.60 into 2.68 into 1000, which will be 1103 kg. Everything is given. If you want to see the specific gravity, go back here. Here they have given the specific gravity. Yeah, 2.68 is a specific gravity for coarse aggregate and 2.65 for fine aggregate. So same thing you can see here. Yeah, you have taken 2.68 for coarse, and for fine aggregate they have taken 2.65. Do this calculation. Okay, if you are done with that, yeah, you'll get the final answer. Final answer, they have not written it here. Okay, they have written it here. Therefore mixed proportion for the trial number will be cement is 383, water 191, fine aggregate 727, coarse aggregate 1103, and water cement ratio is 0.5, right? Similarly, we'll take another problem and finish off. It will not take much time. Yeah, again for M30 you have to prepare, no, same question, nothing changes, will not go in detail again. Okay. Yeah. So what you're supposed to do? First thing first, F dash CK is going to try to do this. Standard deviation will be 5 here because the grade what they have given is M30. Corresponding to M30 grade, our standard deviation is going to change. For M30, the standard deviation will be 5, right? Yeah. So 1.65 into 5 you do. Selection of water cement ratio will adopt it as 0.5. And right, if you take 0.5 now, directly you don't have to put that correction factor. That is why you will take will take 0.5. So here again there is no admixture used, so whatever answer you're getting, yeah, here you see here one thing you need to understand here, what is the slump given for us in this question. Yeah, so the workability what they want is 25 to 50 is the slump they require. That means our table is also made for 50 so again you don't have to put the correction factor here. You can see it here, no? Estimated water content for 50 slump is 186 liters. That means if I go back here, this value you have to take directly 186. Yeah, so this table is made for 50 and for angular aggregate, right? So for 20 you have to get 186. This is for slump of 25 to 50 in the question also they have given the same thing, so we directly add 186 in the answer. You don't have to do this correction factor in this particular problem. Yeah, so that is why you can say 186 is directly written. Cement content will be 186 divided by water cement ratio. They have taken it as 0.45. Okay, based on the experience, adopt a water cement ratio of 0.45. Okay, here they have taken water cement ratio of 0.45. We'll take that only, no issues, right? But then you have to put a correction factor. We'll see that how to apply again. Yeah, so this is also okay. 413 is what I'm getting, which is greater than 350 given in the code book. That is also okay. And therefore minimum cement should be 300 kg per cubic meter. Hence this is also okay. Yeah. Next thing is that this correction factor you have to apply, since we have taken a water cement ratio of 0.45, no? Yeah. For this, what you are supposed to do, go back to the question. See in the question what is given. In the question, my fine aggregate belong to which fine aggregate belonging to zone 1, right? For zone 1 the fine aggregate is belonging to zone 1. So again same, this we will know. For water cement ratio 0.5 we are getting 0.60 from the code. Quickly see that. Yeah, for 20 aggregate, and for zone 1, 0.60 is getting, we are getting, but this is for 0.5 water cement ratio. We have adopted a water cement ratio of 0.45. Then you have to apply that correction factor. Now you know how to apply that correction factor. Okay, so for 0.05 change of water cement ratio, the volume of coarse aggregate is increased by 0.01. So try to do this cross multiplication. We'll do it. Yeah. So what is given here? See, water cement ratio for 0.5. This is given. We have adapted 0.45. Right now, now do this thing from 0.5 to 0.45. What? How much is the decrease? The decrease is how much? 0.05, isn't it? Yeah. So if this is very straightforward now. If you refer the code here, it's given for every increase or decrease of 0.05 in the water cement ratio, the above value will be decreased by 0.01. Straightforward, you have to take 0.01. Yeah, straightforward, right? We're also getting 0.05. Therefore, for 0.05 change in the water cement ratio, volume of coarse aggregate is increased by 0.01. Now, since we are decreasing from 0.5, we are coming down. So we have to increase it by 0.1. Hence, 0.6 is what we have got. For that, we'll try to add 0.01, which is equal to 0.6. So this is the volume of coarse aggregate 0.61, and volume of fine aggregate will be 1 minus 0.61, which will come out to be 0.39. Another thing we need to understand here, the thing is that here we are not going to do any pumping and all. Since we are not going to do pumping and all, no, I'll write it here, no pumping. If you refer the previous to example what we had done there, since we are using a pumping, what we used to do, we used to reduce this volume of coarse aggregate by 10%. But here we are not doing a pumping. It is given in the question that yeah, yeah, they're not mentioned anything here how you are going to do the placing. So let us say they are not making use of pumping. With the help of that chute, they are going to do the placing. So hence it is okay. We have to ask all those things when we try to do the mixed design, no? Because if you are pumping, then you have to reduce this. Since we are not doing pumping, it's okay for us. We'll not decrease this content of coarse aggregate. Yeah, so you got up to here it is 0.39. Next remains very same. Volume of cement will be mass of cement by specific gravity. Mass of cement we got 413 divided by 3.15 into 1 divided by 1000. Volume of water will be mass of water divided by specific gravity divided by into 1 by 1000. 186 is what we got, divided by 1 into 1 divided by 1000. 0.186 we got. Volume of all in aggregate will be 1 minus 0.1 minus, open the bracket, 0.131 plus 0.186 will give me 0.683 cubic meter. Therefore, mass of coarse aggregate will be this answer, 0.683 into specific gravity of coarse aggregate that you are going to get from here. Specific gravity is already given in the question. Yeah, coarse aggregate is 2.68 and 2.65. Add that 2.68, and then the volume of coarse aggregate we got it from here, 0.61, that is put here into 1000, 1117 kg. Mass of fine aggregate, same calculation, instead of 2.68 put the specific gravity as 2.65, and here the volume of fine aggregate is 0.39, put 0.39, 706 kg. That's it, finish, write whatever answer you're getting here, right? Yeah, so this was all about the mixed design that we need to understand. Now one thing you need to understand, so far what we did, no, everything is from theoretical point of view. Practically, you need to put a moisture correction. The coarse aggregate what we get and the fine aggregate what we get, no, they will not be in a SSD condition, that is saturated surface dry condition, right? So there are chances they'll absorb the water, there will be moisture and all that. Moisture correction we need to apply, only then we can make use of this. Here, since we're doing it theoretically, we don't have any challenges, but practically when you do, we'll be having a challenges to apply the moisture corrections in the fine aggregate and the coarse aggregate, and corresponding to that we have to reduce the water content, right? So maybe in the next lecture I'll be taking you to those things, but this is not required from your examination point of view. This is enough. In examination they are going to ask all these things, but we have to make ourselves ready for practical field. So in the practically, when we do mixed design practically, we have to apply those mix correction for the bulking of fine aggregate and coarse aggregate. Those things we'll try to do in the next lecture, right? Yeah, so we'll see you back in the next lecture. Thank you.